Hey, welcome to the Explainer. What if I told you that one of the most powerful tools you're already using has this secret superpower? Today, we're going to unlock it. We're going to turn your plain old Postgres database into a super reliable message queue. So let's just dive right in with a question that I'm sure every single one of us has asked ourselves at some point. Is my application architecture just way more complex than it needs to be? Are we just adding new tools and services for the sake of it, when the perfect solution is already right there, sitting in our stack? All right, so here's the problem, and it's a super common one. Your app needs to do something heavy, a task that's just too slow or resource-intensive to make a user sit there and wait for it to finish. And we have a name for these, right? They're called asynchronous tasks. The whole point is to just offload them. Let them run in the background so the part of your app that the user actually sees stays super fast and responsive.
And I'm talking about really common stuff here, things like sending a welcome email or generating an invoice, maybe processing a video someone just uploaded, or even just resizing a profile picture. I mean, this is the bread and butter for so many applications out there.
Okay, so how do we usually handle these kinds of background jobs? Well, the textbook answer, the one we all learn, is to bring in a dedicated message queue.
And this is the classic setup, right? It's been around forever. A request comes in, your app shoves a job onto a message queue, you've probably heard of RabbitMQ or Kafka, and then you have these separate worker processes that just sit there, picking up jobs and doing the heavy lifting.
And look, this approach totally works. It's solid, but it's not free, not by a long shot. You've just bolted on another huge piece of infrastructure to your stack. Something else you have to provision, something else you have to monitor, and yeah, something else you have to pay for. It's another point of failure, and it just makes the whole system that much more complex.
But what if there was a simpler way? I mean, what if we could get all the good stuff from a message queue, but without all that extra headache and overhead?
And this is the big idea right here. Instead of adding a whole new service, let's just use the power and reliability of something we already have, our database, the thing that's already at the heart of the application. By using Postgres, our jobs get that same all-or-nothing transactional integrity that our main application data has. That's huge.
Just look at how clean this architecture gets. That whole external message queue, gone. Poof. Now the backend just writes a job into a table in our database, and the workers read from that same table. It's so simple, so direct, super efficient.
So how do we actually pull this off? Well, it's surprisingly simple. We just need to create a new table in our database, let's call it jobs. And it's pretty straightforward. It needs a unique ID, a task type so we know what to do, like send email, a payload for all the data the job needs, and this is the key part, a status column to track if it's pending, processing, or done. Oh, and it's a good idea to add an attempts column too, for handling retries. Okay, this sounds almost too good to be true, right? And you'd be right. There's a huge, huge catch. If you just go and query this table from multiple workers without thinking, your whole system is going to break. And it's going to break in a really subtle, dangerous way. The problem is a classic bug that I'm sure you've heard of, a race condition. It's what happens when multiple things, in our case our little worker bots, all try to grab and change the exact same thing at the exact same time. The results? Totally unpredictable and, honestly, often disastrous. So let me walk you through how this blows up. Worker 1 asks for a job. At the very same microsecond, Worker 2 asks for a job. The database looks, sees a job with a status pending, and just hands the same job out to both of them. And just like that, you're processing the same job twice. This could mean sending a customer 2 identical emails, which is annoying. Or it could mean charging their credit card twice, which is a total disaster. But don't worry, this is exactly where Postgres shows off its hidden superpower. It has a built-in feature that is so powerful, so elegant, and it's designed to stop this exact problem dead in its tracks. And here it is. These 4 little words are basically magic. You just tack them onto your SQL query, and the entire race condition problem, it just vanishes. It's a simple command that tells Postgres exactly how to deal with all those workers clamoring for a job and to make sure only one worker can grab any single job. All right, let's break this down because it's actually really cool. The first part, for update, is basically your worker telling the database, hey, see this row I'm grabbing? I'm going to update it, so lock it down for me. Nobody else gets to touch it until I'm finished. Then, the second part, skip locked, is just as important. It's a message to all the other workers. It says, hey you, if you see a row that's already locked by someone else, don't just stand there waiting. Just skip it, move on, find the next one that's free. So, with that little bit of magic in place, the whole flow is now, well, it's perfect. Worker 1 comes along, its query finds job 37, and bam, locks it instantly. Then when worker 2 shows up a millisecond later, it sees job 37 is locked, and thanks to skip locked, it just says, okay, no problem, and moves right on to grab the next available one, job 38. Every worker gets its own unique job, no duplicates, no race conditions. It's beautiful. Problem solved.
So why does this matter so much? Let's recap the benefits, because they are huge. First off, way less complexity. You have 0 extra services to manage, debug, or deploy. Second, it's cheaper. You're just using the resources you already have and are already paying for. Third, and this one's a big deal, you get real transactional integrity. Your jobs live in the same place as your data, so you can do these powerful all-or-nothing operations that are so much harder with a separate system. And at the end of the day, it all just adds up to a system that's way, way easier to maintain.
And really, that's the big takeaway, isn't it? The tools we use every single day are often way more powerful than we give them credit for. It really makes you wonder, right? What other amazing superpowers are just hiding in plain sight, just waiting to be discovered in the tech we already know and trust?